Hello and welcome back to our instructional series. In today's session, we'll explore how to seamlessly automate Border Zero resources using the powerful capabilities of Terraform. Let's dive in and simplify our infrastructure management together. Before we begin, we need to check out our Terraform examples repository. Link in the description. Once we cloned it into our selected directory, we can now follow the instructions in the README file to set up our environment and credentials. Speaking of which, service accounts and their tokens are essential for secure, automated access to resources. They enable scripts and applications to interact with our platform without human intervention in a programmatic way. For more information, refer to our documentation linked below. Right, so following the documentation, we've returned to the admin portal. Let's go ahead and create a service account together. When we select the name, we should remember to make it URL slug compliant. Now, since we're managing users in this particular Terraform example, grant admin privileges. Next, we'll create a token for our new account. Make sure to select the appropriate expiration date, and don't forget to copy the token and keep it safe because, remember, you won't be able to retrieve it again. Okay, we need to open the variables file with our favorite editor, put the token in and save. We are ready to run our Terraform. All right, before we dive in, let's go over what we're going to create. First, we'll set up a new connector and generate a token for it, along with the configuration file we'll use to run it. Next, the code will create 3 different types of sockets. We'll have an HTTP socket with minimal configuration, an SSH socket with a static username and password, and finally, a database socket for a MySQL server, also using static credentials. Let's get started. Before we initialize our Terraform environment and apply our code, just a quick reminder about the software. We need to have Terraform and the Border Zero CLI tools installed. Enough talking, time to run things. Starting with Terraform init, followed by Terraform apply. And we'll say yes to confirm. Once everything is set up, we'll be provided with a command and a portal link. We'll copy the generated CLI command and execute it. With the connector running in the background, we can then head to the portal and explore our new resources. The dynamically generated link takes us directly to the connector landing page. Here we can see runtime information, log history, and geolocation details. We also have navigation tiles available. Let's select sockets and explore further. Here are the sockets we just created. Let's go over them, shall we? Starting with the SSH socket, the portal shows it pointing towards the playground with static username and password. Okay, let's connect. Voila, we're dropped into the shell of our Terraform provisioned SSH socket. Time to check the other ones. The HTTP socket is next. Here's our simple config. All right, clicking connect. And there it is, our Terraform provisioned HTTP socket. Now, it's time for the last one, the MySQL database socket. Once again, our configuration defined from the Terraform file. We'll click connect, and here we are, our Playground MySQL server. One thing to notice is that we have unrestricted access. Maybe a bit too unrestricted. Let's see how far we're allowed to go. Let's try deleting something from one of our tables. Whoops, that's not good. We managed to delete an entry from our database. The reason for this? It's our rather permissive default access policy. Upon inspection, we see that all database type access is allowed. To control the access a bit more granularly, we'll create a new policy with Terraform. But first, let's delete the existing one. All right, back to our favorite editor. Okay, we'll jump to the policy.tf file, which contains a new policy definition for our demo user, Greg. In the policy resource, we declare that only the database named books is allowed with query type set to read-only. Our resource creation is controlled by a variable, so we'll set it to true, and switch back to the terminal. For now, we can exit out of our connector process and apply the new Terraform-driven policy. All right, state changes have been detected. We can see our new database permissions being put in place. We'll confirm the changes. then start the connector back up just like last time. Type in border 0 connector start --config border0.yaml. Next, we'll return to the portal and check out the new policy. That's more like it. The database section has listed only books, and the allowed query is set to read only. Our demo user is also defined. That looks perfect. All right, we'll revisit our database socket and check out what's available to us this time around. As stated in the policy, the only database we have access to is books, and nothing else is visible. Okay, let's check the write restriction. Can we delete another row, maybe? The delete query was not allowed this time. This is exactly what we intended. Since we attempted something that wasn't permitted, there is now a trace of that action. We can find it in the portal. Looking under our database socket, sessions tile, we can find our current session with flagged events. We should check for more details. And there it is, our delete query listed as denied. This brings us to the end of this session on Border Zero infrastructure as code. We covered the basics of setting up and configuring your environment, demonstrated how to deploy resources using Terraform, and explored the resulting infrastructure via the portal. By now, we should have an understanding of how to automate Border Zero with Terraform, so stay tuned for our next session, where we will dive deeper into advanced Border Zero features and best practices. Thank you for joining, and happy coding.